My dear students, I am very happy to see you today. Today, we will get the important lesson. Sure, we must say the important. Do you know why? We have here different solutions. I want to know what is the acid, what is the base for each one. When I get lemon, you remember? Lemon here is what? Acid? Yes. Concentrate here. The color, is it change? Yes. What this? It's a vinegar. Add drops of the vinegar. Vinegar is what? Vinegar also is acid. Why I make that? To make acidic medium. When I get this and I put it in this paper, one for the vinegar, one for the lemon, and the third one, as you see, more of the water and vinegar. I try now to see what is the effect for each one. Do you think the color will change from one to another? Look here, concentrate, I see the color change. Why? Because the indicator changes the color from medium to another. You see this different indicator, methyl orange, phenophenol, thymol, and so on. Bromomethyl orange, blue, bromomethyl blue, yes, also can be used. When I get bromomethyl blue and I add for this, look, neutral H3O, hydronium or hydroxynium equal OH what? Equal OH negative. It means neutral solution. Hydronium equal hydroxide. H3O, 10 power negative what? Negative 7. This is pH. Hydrogen chloride, I know it's a gas. Look here, I put it here. You see, the reaction here is happen. It's a neutral solution. HCl, a water, give me more hydronium. H3O and the Cl gas is evolved. You see, this reaction is not easy, but it's very important to tell me about the solution. Change it to what? Yes, acid. Hydronium becomes more good than hydroxide. I have acidic solution. Here I get sodium hydroxide. I add more of NaOH to the water. Why I do that? Here there is a change happen for this reaction. Form OH negative. OH negative. Yes, we know this. It means a basic solution. It means hydronium H3O less than OH. Is the opposite of what? Is the opposite of the acid. What about when I add drops of bromomethyl blue? The color is a change for the acid. Also, the color is a change for neutral. Look at the last one. What its color? Change or the fixed? Sure, will be changed. Oh, different colors from yellow to colorless to the pink. Yes, the color is a change according to changing of hydronium and hydroxyl group. Neutral, this is acidic, becomes what? The color is changed also, as you see. Now, what control the changing for this color? The changing color depending on the amount of H3O or OH negative. Positive and negative, hydronium and hydroxyl group control the changing for the color from the blue to pink to colorless. It's easy to understand all of them. This is the molecules. When start to change, as you see, good. Change its color Why become, as you see, pink, red, acid? Why it's happened like this? Due to increase H3O positive. What about the bases? The bases, the color must be changed by the different one. Look at the molecule. Here, the other molecule for agent to start. What this? It's a hydrogen, I know. B, yes, will be HBB. Look at this. H here appear. Appear, it means what? It means you have acid. B, negative, we know it well. As you see, pH value is a change from acidic to basic. If I have H, as you see, HMO, I ask, H here? Yes. It means what? It means the acid. Acid, it means what? pH less than 7. It's good to say that. It means less than 7 may be what? May be good as 5, 6, 4, 2, 1, 0. It depends. So K, concentrate, equal concentrated hydrogen by the element over concentration of the product, reactants. Product over reactants. You see, pH 10 power what? Negative 4. pH, it means 4. 4, it means what? 4, it means less than, good, less than 7. It means what? It means acidic. 10 power negative 4. You see, it's good. This is the power. The normal one, neutral one, 10 power negative 7. I have acidic. So 10 power 7, it means neutral. What I need now? I need a basic. Basic, it means more than 7. I can control by this reagent. I add drops here of the methyl orange for each one. You see the color is a change from substance to another. When I ask you, why is the color here is a change? All of them acidic. I'm sure it's acidic. But why? I say here the color is a change according to the concentration of the gas, of the hydrogen gas. So the color for one reagent is changed from 10 power negative 4, negative 5, negative 3, and so on. Here we have a phenol, add different reagent. Also we can find changing for the color by the same steps according to the concentration of hydrogen ion. It's important to know that. But here I have what? I have a basic. How can I know? Because the numbers 10 power negative 8, 10 power negative 10, oh, it means I have different basic. So changes the color of indicator depending on two main factors, H positive and OH negative, acidic or basic. Between them, I have neutral solution. It's good and important. Yes, my dear. MB, here it means concentration of what? Of base. You can say what here? MB, it means concentration of alkali used, basic used. It means mole per liter. Also, V volume. Volume, yeah, of alkali by liter. Now, NB, number of moles. As what? As acids. Number of the moles of alkali. Na, number of moles of acid. NB, number of moles of alkali. Shown in this chemical equation. Types of indicators. Look at this. This is the indicator. This is the color in acidic medium. This is the color in alkaline medium. Look. Methyl orange. Acidic medium red. Alkaline medium yellow. It change or not a change? Change. Why? According to changing in two main factors, H positive and OH negative. H3O positive, OH negative. Catch number 2, phenol, phenolphthalein. You know, the colorless for acidic, but the alkaline will be red, different colors. Catch it now. Litmus solution, red, blue. Yes, I am sure. Red and blue according to acidity and basicity, acid and base. Last one and the important one, blue bromothymol. For the acid will be yellow as we saw it before, and the color of alkaline will be good, blue, yellow to blue.
Titration. For this I can say I have hydrochloric acid. Also I have sodium hydroxide. When I ask why them, because both, it means neutralization. As a beginning, I have hydrochloric acid, MaVa, concentration of the acid and its volume. All of them over what? I say over Ne, number of the moles for the acid. But when I back to the B's, I can say MbVb, the same concentration of the sodium hydroxide and its volume. Also over what? Mb, number of the mole, good, number of moles of what? Of base. Now, I can say 0.1 by 21, all of them over 1. 1, it means what here? It means we use 1 mole. For the other one, M2, this what I need because I want to calculate the concentration of sodium hydroxide by its volume 25 over what? 1 mole. Also, cross multiplication for them, I can find the result. Example, tell me about 20 milliliter calcium hydroxide, CaOH multiplied by 2. This is what all time I say its base. Was titrated. Titrated with what? Titrated with about 0.05 molar hydrochloric acid at the end of this reaction. Also, you have 25 milliliter of the acid was consumed. Okay, what I need now? I have acid and I have a base. The question here, calculate the concentration of calcium hydroxide by mole per liter. It's impossible to write this problem or answer this problem because I need here to write the equation. So, solution as 2HCl in its aqueous solution plus what? Calcium hydroxide, CaOH by 2. What you have now? I have acid and base. When titrated together will be CaCl2, calcium chloride. Also, I have a what? I have a water. It means salt and water. My dear, I have 2HCl. I have 1 molecule of CaOH by 2. Can you answer? Sure. Now, what about to make a substitution? MaVa over Na. Do you know what this means? This is the concentration or the law that follows the acid. For the other side, MpVb over Nb for the base. This is the law that I need and obtain the full mark. Also, I can say for this case 0.5 by 25 over, good, 2, because 2 HCl, 2 molecules. The other side, M2 by 20 over what? Over 1. 1 what? 1 mole of the base. Cross multiplication for this, find the answer. Concentration of calcium hydroxide, it means here Mb. Mb equal, look, 1 by 0.5 by 25 over what? 2 by 20. What this mean? Now, this it means concentration of the base. Result? Yes, I have a result. 0.0312. What? Mole per liter. This is the unit of concentration of the base. care for the other example. Here I have question. 0.1 gram of the mixture of solid substance containing sodium hydroxide. What is sodium hydroxide? Sodium hydroxide here, it's base, I know. Also, I can say, and sodium chloride was titrated. Titrated with what? 0.1 molar. Oh, I have a molar here. It's okay. 0.1 molar of what? But hydrochloric acid. Okay, I have acid and what now? Acid and base. It means we have titration. My dear, catch this now. To complete this reaction, ending point takes place by consumption of 10 milliliter of the acid. What do you want? Calculate the percent of the sodium hydroxide in this mixture. Titration here, it's okay. What I need percent. How can I do? How can I answer? I can say solution. As a beginning, the number of the moles for hydrochloric acid that used. I must know them. What this will be? I can say equal 10 by 0.1 over 1000. I have now 0.001. Yes, I need number of the mole for acid. It's okay. It's right now. This only? No. I can say mole because I calculate the number of the mole. After that, I can say HCl 1 mole plus what? Plus NaOH, sodium hydroxide. This is a base also by 1 mole. It's good to say that because I use for each one just 1 mole. After that, I have exchange, neutralization will be solved as you see in ACl 1 mole and water by 1 mole. So when I ask what is the number of the mole that is used for acid and base, HCl, it's 1. NaOH, it's 1. It's okay. I have a titration. After that, from the balanced chemical equation, it's known that 1 mole of sodium hydroxide react with 1 mole of hydrochloric acid. It means the concentration of sodium hydroxide in this case equal what? 0.001 mole per liter. Look at this. I can say 1 mole sodium hydroxide equal what? 40 grams the mass of sodium hydroxide in this mixture. Why I say 40? From where? This 40 back to the molar mass of sodium hydroxide. Then I can say here equal 40 by 0.001. What you have? I have an answer 0.04. It's a good mole. This about the sodium hydroxide. It's easy to catch the problem. Can I find the percent now? Sure. Percent of the sodium hydroxide in this mixture can be as 0.4 by 100. Only? No. Divided what? 0.1. So what you have, I can find 40%. You see, now I arrived to the good answer, this percent. I have a what? 40% of what? Sodium hydroxide after calculation of molarity and number of the moles. Catch the other one. The method depending on separation and determination of the mass of analyte and by using what? By using chemical calculation. The quantity of analyte can be measured? Yes, can be measured through different examples. The approaches are used for analyte separation. Look at this. Volatilization method. Do you think what this means? It means here it's a process that is used for these reactions. Also, precipitation, yes, we can use second one, precipitation method. All of them help me for calculation because I want to calculate all of them. Look at this, volatilization method. Do you think what this means? It means here the method is based on volatilization of the element or compound Y to be determined, followed by the measuring either by calculating the volatile material and determining its what? Determine its mass. Easy and important. By the same method, I have other one. Or measuring. By measuring what? Measuring the amount of lost from original mass. You see? Of what? Of the same substance. This is the other one. Catch the example now. This example tells me about 2.6903 grams of hydrated barium chloride salt. What its formula? BaCl2.xH2O. After that, was strongly heated until a constant mass. This constant mass equal what? 2.2923 grams. It's good. Heated here, it means get rid of water. So I say strongly heated. After that, calculate the percent of the water of crystallization of hydrated barium chloride. Can I answer this problem? Sure I can, but concentrate. You must find what? Find the number of moles. Find the number of the water moles, molecules by crystallization. After that, write the molecular formula of this salt. This problem has many steps. To answer these steps, I must know oxygen, its molar mass or atomic mass 16. Hydrogen, atomic mass 1. Chlorine 35.5. Barium 137. Why this number? Because this number helps me to calculate the molar mass for different compounds. Now, what about to start? Solution here is beginning with mass of the water of its what? Crystallization. Can I say? Yeah, 2.6903. He told me that. This is mass of water minus 2.2923. Oh, why I make that? The first number for all mixture. Second number for the solid substance. The difference between them will be water. 0.0, good, 0.398. What this? It means the mass of the water in grams. Good. What I have now? I have two important masses. One for solid, 2.2923. The other water, 0.398. What I want after that? It's easy. Now, the mean that 2.2923 grams of anhydrous. Anhydrous, it means pure good substance, pure solid barium chloride. Hasn't water now. The water that added to it will be 0.398 grams of the water of crystallization. It's good to know these masses. What can I do after that? I can say percent of the crystallization of the water here equal what? 0.398. This is the mass of what? The mass of water over good 14.79%. Now, all of them by what? By 100. Calculate it now, equal to 693. Good. After that, the molecular formula for this case, barium chloride equals the mass of, look, the mass, oh yes, I know, this is molar mass of chloride. I can say 137 plus 71. 71 from where? It means 2 by 35.5 equals 71. All of them equal 208 grams. This is especially mass barium chloride without the water. Now, my dear, I can say 40 grams of the mass of sodium hydroxide in this mixture equal 40 by 0.01 equal 208 grams. All of them for what? This moles, grams, it's okay, never mind. Combined with X gram of the water crystallization. X mass of the water of crystallization in this molecular formula equal what? 2.8 by 0.398. All of them over what? Over 2.3. What you need now? 36.114 grams. Now, my dear, molecular mass of the water here 1 by 2. We know 2 hydrogen. You see, H2 plus 16 by 1, it means the oxygen will be 18. The number of the molecule of the water crystallization equal 36.114 over what? 18 from the water. All of them equal what? 2.00 molecules, 6 molecules. Do you know what this means? This is the number of the moles of the water. I catch it now. After that, my dear, I say the molecular formula of hydrated. Hydrated, it means must we add the water. Back to what? BaCl2, this is barium chloride. XH2O will be 2H2O. Why? Because I have 2 molecules of the water. Now you catch this formula. I think it's easy.
We arrived to the end of the lesson. Do you think you understand it? I think so. Study it well to get a full mark. I'm waiting you to tell me your opinion about the lesson. My dear, see you soon. Thank you and goodbye.